Determine f prime of x and f prime of 1 for the given function. We have f of x equals 2x to the 7th times inverse hyperbolic sine of 5x. To determine the derivative, we need to apply the product rule of differentiation, where the first function is 2x to the 7th, and the second function is inverse hyperbolic sine of 5x, which indicates f prime of x equals the first function of 2x to the 7th times the derivative of the second function, which is the derivative of inverse hyperbolic sine of 5x, and then plus the second function of inverse hyperbolic sine of 5x, times the derivative of the first function, which is the derivative of 2x to the 7th. And now we determine the derivatives here and here. To differentiate inverse hyperbolic sine of 5x, we apply the derivative formula shown here, where notice in our case, u, the inner function, is equal to 5x. So if u is equal to 5x, notice this indicates u prime equals 5. Applying the derivative formula, the derivative is equal to 1 divided by the square root of the quantity u squared plus 1. Well, if u is 5x, u squared is the square of 5x, or 25x squared, indicating the radicand is 25x squared plus 1. And then times u prime, where u prime is 5, plus inverse hyperbolic sine of 5x times the derivative of 2x to the 7th, which is 14x to the 6th. Let's go ahead and simplify and write f prime of x as, well, 2 times 5 is 10. Let's write the first product as 10 x to the 7th divided by the square root of the quantity 25x squared plus 1. And let's write the second product as 14 x to the 6th times inverse hyperbolic sine of 5x. And now that we have f prime of x, we can determine f prime of 1 by substituting 1 for x, which indicates f prime of 1 is equal to 10 divided by the square root of the quantity 25 plus 1, giving us the square root of 26, and then plus 14 times inverse hyperbolic sine of 5. So this would be the exact value of f prime of 1, and now let's evaluate this on the T84 as well as using the Desmos graphing calculator. It does not matter whether the calculator is in degree or radian mode. On the T84 we enter 10 divided by secant x squared for the square root, 26, right arrow, plus 14. For the inverse hyperbolic sine function, we will use the catalog by pressing secant 0, and then we'll go down to s by pressing the letter s. Notice the s is in green here above the natural log button, and therefore we press natural log, and the calculator jumps down to the s's. And then we scroll down to inverse hyperbolic sine. Here we have inverse sine, here we have hyperbolic sine, and finally we have inverse hyperbolic sine. With the arrow on inverse hyperbolic sine, we press enter, 5, close parenthesis, and enter. To 4 decimal places, we have approximately 34.3353. Let's also show how to evaluate the derivative function using the Desmos graphing calculator, which is a little bit easier. We simply type in the derivative function value as 10 divided by the square root of 26, right arrow, plus 14, and from here we can simply just type in the inverse hyperbolic sine function. Right arrow, open parenthesis, 5, close parenthesis, and enter, and we can see we get the same derivative function value, approximately 34.3353. I hope you found this helpful.